This episode of Star Talk is supported by Progressive Insurance, where customers can save an average of over $750 when they switch and save. Visit Progressive.com to get your car insurance quote. It only takes about 7 minutes. National annual average auto insurance savings by new customers surveyed in 2019. Potential savings will vary.
From the American Museum of Natural History in New York City and beaming out across all of space and time, this is Star Talk, where science and pop culture collide. This is Star Talk. I'm your host, Neil Degrasse Tyson, your personal astrophysicist. Today, we're doing cosmic queries. Topic, the edge of space-time, the edge of the universe. Chuck.
Hey, Neil.
You going to join me there?
I am.
But we can't do it alone.
And that shirt.
You know, whether you're watching or listening, that I wear cosmically colorful clothing.
Yes.
But my shirt I'm wearing today is particularly cosmically colorful.
Yes.
It's in your face. It's smack down. It's...
Well, you're going to have to go to Patreon, or maybe we'll take a picture of it and you'll have to see it on our website, or maybe you'll see it on YouTube, but you got to see this shirt. Seriously.
It's some pretty lovely celestial bodies going on there.
We have Janna Levin to help us.
Yeah.
Janna,
Always glad to
Professor
be
of Physics,
here.
Barnard College, Columbia University. Welcome back.
I love being here.
We needed you
Great.
for this topic. Because my knowledge of cosmology is little and yours is big.
not as big
As the universe itself. Okay. All right. So anytime we do a cosmic queries,
Right.
we bring her in.
I love it.
We bring in the big guns.
This is, and Janna is the big guns, man.
Right.
Yeah,
All right.
good stuff.
So what do you have?
So we got cosmic queries as we glean from all over the internet, and of course we always start with the Patreon patron because
Well,
these
just a quick
people-
sec. Your book, Black Hole Blues.
Yeah.
That's still out there.
Yeah, it's still out there.
Okay, Chuck, we got to do it.
Black Hole Blues.
Greatest. I've got to learn a harmony to that. So I can be like, over here.
There's got to be a way when someone picks up the book, it says,
I was Black Hole Blues.
guaranteed more
Or
sales.
what if you just, every time you walk past it on the shelf?
Oh, you just heard it.
Yeah, that'd be so cool. Yeah.
It's hey.
We got to
With
put
a
it on
little
your shelf.
riff, with
right
a little
about
riff
here.
behind it, you know? Black Hole Blues. No.
So that was about the discovery of gravitational waves
Yeah, so...
moving through the universe.
Yeah, exactly. So right before that succeeded, in the 50 years it took them
Before
to
we
succeed.
successfully measured it.
Yeah, Ray Weiss, who's one of the original architects, just was shaking his head and saying, if we don't detect black holes, this thing is a failure. So like the whole title was just kind of like, it's the Black Hole Blues.
Sweet.
But then he detected it, so
Yeah.
you got a new title?
Yeah, the new
Black
title is
Hole
called
Jitterbug.
Nobel Prize winner.
The Black Hole Nobel Prize.
The Nobel Prize jig.
He's sad all the way to the bank on that one. Yeah.
Nice.
All right, so good to hear it's still out there.
Yes, thank you for that.
Let's start off, though, with the Patreon patron. This is Chris Hampton, who supports us on Patreon, who wants to know this. Could it be that the universe that we are in is actually finite? However, the universal structure is infinite via size and relativity, meaning the universal structure gets infinitely smaller and vice versa, kind of like infinitely dividing in half. I imagine it would look something like a very complex fractal.
Well, he's going a
He's
lot of
going-
places. He's
Wow.
taking that. All right, Jen, take that however you
I
want
want
to.
to. I'm gonna write.
And I have a
love
question
it.
for Chris first. Is it sativa or indica? Sativa? Indica. Okay. Good.
Which is the one that he would have fallen asleep before making it to the end of the tweet?
Not the sativa.
I think that I don't
Is
know.
that the end?
I, maybe that's the indica.
Okay,
I
well,
don't
we
know.
just all revealed our
Yeah. When I actually used that substance, it was called weed. They didn't put any other name on it.
Right.
Like if you went to
easy to pronounce
right,
and remember.
that was it. Right. If you went to your dealer and you went, so now is this sativa or indica? He'd be like, man, what's wrong with you? Smoke it. Get the hell out of my house. Go smoke that and get out.
Perfect.
Anyway, so you want to take a shot at this?
I'm into this.
Okay.
So my first book is about whether or not the universe is infinite or finite. It's a question we don't know the answer
And the
to
title of that book?
yet. How the Universe Got Its Spots.
I remember that, yeah.
So How the Universe Got Its Spots is about, could we tell the shape and size of the universe by looking at the hot and cold spots in the Big Bang and the light left over from the Big Bang. But the question, let's just take it really theoretically. We absolutely do not know that the universe is infinite. And it may well be that it's finite the way the Earth is finite, that, we leave New York City, we travel in a straight line. Maybe we'd have to swim a little, get on a boat, but you travel in a straight line, you're going to come back to New York City again. Right. And so it could be that
But you can travel forever.
I was going to say, it's infinite in what you can travel and where you can travel.
It's infinite in you don't get to an edge.
Right.
You never get to an edge, which is beautiful. So exactly the same thing with the universe. You're not going to sail off the edge of the Earth, right? Like, Spanish explorers waved goodbye and wondered, right, if they'd just go off the side. But no, we know that's not what happens. And so similarly, we could leave the Milky Way galaxy. We could watch it recede behind us. We could travel in as straight a line as possible and find ourselves coming back to the Milky Way again. Wow. And it's so Planet of the Apes, right? It's like,
damn you!
Yes!
You finally did it! Yes. Damn you all the hell! Oh, that'd be
so great. So my interpretation of that was that they went all the way around. Yeah. Mm-hmm. And so the interesting thing is that also means that if you look at distant galaxies, the light is also traveling all the way around the universe. So it could be that some of those distant galaxies are the Milky Way, and we're seeing the light from the Milky Way wrap all the way around and come back to us. So we'd be seeing the Milky Way in the past. Wow. So it would be hard to know. Like maybe we'd see an active black hole quasar with jets flying out in the early phases of the Milky Way, and we'd think, oh, that's just a different galaxy.
Oh.
Wow.
Yeah. So
because galaxies, young galaxies look very different from mature galaxies.
Right.
And we used to think that there were different kinds of objects in the outer universe, like quasars. Why are they all distant? How come there's not a quasar right next door with these monstrous nuclear emissions? And we had to figure out that it's likely just younger galaxies, and maybe we used to look like a quasar and we don't anymore.
Right. So even a distant galaxy looking back at us is seeing us in the past, given the light travel time. So we could still look like a quasar to a distant galaxy. Wow. Like have this huge active galactic nucleus.
Because they are not seeing us as we are now.
No, they are not.
They're seeing us as we were.
Billions of years ago. Yeah.
Oh my God.
So that's the beauty. We get to see in the past.
I need some of that sativa right now. Wow.
Well, and then it gets more because there are reasons that people start to suspect that there are extra spatial dimensions and that they are not only finite, but really technically really small. Like that journey to go all the way around them is something that would happen incredibly quickly, and it's too small for us to literally stick our hands in that direction in some sense. So we're looking everywhere. Those extra dimensions are everywhere, but we can't actually notice them.
Wow.
And so
what does it mean for a dimension to be smaller than another dimension? What does that even mean?
So think of a straw as a good example, where it's a two-dimensional surface.
You know what the first straws were made of?
I'm going to go with flax.
No. Yeah, straw. Yeah.
Thank you. Thank you for getting that.
Yeah,
I knew I could make that joke to him. I knew it. Oh, God. All right, go ahead.
The only reason it's because flax and hair.
Oh, yeah?
Yeah, that's the only reason
color.
why I would
flax,
have the
flax
connection between flax and straw.
Flax and hair. Yeah.
So a straw is small in one direction on the surface, right? If you think there's a direction in which it's totally wrapped up and small. And then there's a long direction.
So straws are mostly long.
They're mostly long. And you could glue the top end and the bottom end of a straw to make that long direction also finite. So then you just travel around the line. It could be really big. It could be, a mile around, but still be connected. But it's only a few millimeters around in this direction.
In this other dimension.
So literally the length of traveling before you come back to where you started is smaller.
So most of how you use a straw does not access that other dimension. It's really the length, because you're trying to get the liquid from here to here.
Yeah.
Most of you're using the long dimension of the straw.
So then the question we start to ask is, what if the universe is a kind of space-time origami when it's created in the Big Bang, that all the dimensions are wrapped up in maybe in very complicated ways, like the dimension of the straw being wrapped up, but one dimension just gets very, very big, or in our case, three very, very big. We have three big dimensions. We have time, which is a fourth. So we know there's up, down, north, south, east, west. That's it. You specify those things and you definitely know where you are in space. You specify time and we can actually meet. Right, here we are. But those extra directions just maybe didn't ever expand. And so one of the things even that I'll work on and string theorists will work on, people, is why would only three dimensions get large if those other dimensions exist.
Interesting.
So it could be that we'll understand the large connectedness, finite nature of space by looking in like really high energy accelerator experiments, because people have asked at the Large Hadron Collider, could you perceive these extra dimensions if they exist?
Okay. Wow, that I got to tell you,
Okay,
Chris,
we're done with the show.
Chris, that's okay. And people will
That's an
be
entire show's
We'll be
worth
back
of-
next week. We're just gonna let you think about that. We'll be
It's
back.
a week's worth of
That's
mind blowing.
That is.
That is
Wow.
a big start
That was a big
to
start.
Cosmic Queries.
Wow, man, that's a fascinating stuff. Just fascinating. All right, let's move on to Paul Love, who says, given that,
Is that because you can pronounce his name? That's why we're going to him
let
next.
me tell you something. As a matter of fact, I think I'm just going to call everybody Paul Love.
That's a beautiful name.
Exactly. Paul says this, given that our universe expanded from a single point and is expanding in all directions, how does that not define the shape of the universe as spherical? How could something flat or saddle shape come out of that?
So there.
Wow. Look at that. All right.
Take that, Jen.
Well, it is true. If there is an explosion in space, it tends to have a kind of spherical cloud left over as debris. So when a star explodes, we will see often nebula, and they're like often spherical-ish.
Even beautiful, too. Beautiful nebula.
Very beautiful. And, you know, sometimes they plow into stuff and it changes the shape. But basically, yeah, then you can point inside this debris, you point to where the center of the explosion was.
Okay.
So that's not how it works for the Big Bang. So for the Big Bang, you cannot imagine that the space exists first and that you're exploding into the space.
Right.
It is actually a creation of the space itself. Right. So everywhere
Right.
in the universe was once at the center of the explosion.
Exactly.
There is no plowing out. It's as though, and you can think of it any shape you want. Make some crazy, you know, people like the balloon analogy. So now make some crazy balloon, twisted up crazy thing. And
A poodle.
a poodle.
Oh, nice.
And the whole,
poodle.
a balloon poodle universe. And the whole thing stretches. And the whole thing was once a point. So every single point on that
It's still
surface.
part,
And
right.
people
It's
get tripped
part
up.
of that fabric, if you want to call
Yeah.
it.
People
So the
get
center is
tripped up.
everywhere.
Yeah,
The center is everywhere. We are at the
We
center
are the
of the
center.
Big Bang, as is every other point in space. Is at
Finally,
the center
I'm
of the Big Bang.
But can I say that differently? Will you allow me to say it differently?
Please.
Can I say there is a center. The only way you can access it is to go back in time to the beginning of time.
Well, you could say
Ooh, okay.
You
Oh,
could
man. Talk
say-
about dimensions.
So, you
Yeah,
can access
wow.
the center of all of this only at one
One
point in
point
its
in-
coordinate system,
Exactly.
and it's at t equals 0.
Right.
I would say
And it's there. If timeline is just always
Yeah.
there, there's the center.
yeah, if we're going to be really split space up in very fine-grained terms, this point was at the center back at t equals 0, and this point was at the center back at t equals 0. They just were all closer
together, right.
So the whole
So it's just the collapse of those points at t
Yeah.
equals 0.
Yeah.
Gotcha.
Yeah.
But I like what you said, though, which I think is what people have to really think is
Yeah.
the space itself was created
Yes.
Right.
at the the millisecond, microsecond, whatever,
A
nanosecond.
bajillionth of a second.
Bajillionth of a second.
Yeah.
That's an official fraction, isn't
Right,
it?
right.
A bajillionth.
The bajillionth of a second
Yeah.
afterwards. That space was created then along with everything else.
I think that's like 10 to the minus 43 seconds.
Yeah, that's
which
right.
would be a trillion,
A Planck-
trillion,
a
trillion,
Planck-
trillion, ish.
Okay, there you go. So, right then. So if you think of it that way, because what you're thinking about is these distances between the stuff that we see.
Yeah.
And we think they're empty, but they came from that thing.
Yeah, from the Big Bang.
From the Big Bang.
Yeah. So
God.
a reason why people
Damn,
get tripped
man.
up.
Okay, Chuck just blew a gasket.
I know, man.
We
So crazy.
Chuck, we just lost Chuck.
I love it.
I would love if there was an actual steam effect.
Out of the ears.
Yeah.
Wow. So
Wow.
yeah, wow. Go ahead.
So
yeah, go
here's where people get tripped up with the balloon analogy because it's flawed,
Right.
as are all analogies, is that a lot of people immediately want to point to the center of the balloon, the
Right.
empty space inside. But you got to give up on that. All that exists is the skin of the balloon.
Wait,
That is
but
all that exists.
I'm okay with the center
Yeah.
of the balloon because that's where the balloon was at t equals 0.
Right. So you could think of it, good. I can only consider the center of the balloon as snapshots, like movie frames.
Right.
So it once was there, and then it was a movie frame over here. And
Right,
then it was
but
a
But
movie
the
frame.
center of that same balloon is still now at the outer reaches of that balloon because it came from the center of the balloon.
Right. So imagine,
So-
imagine you painted dots all over the little infinitesimally small balloon, but they were glued to, there's stains on the skin of the balloon. The dots themselves don't move. And then you push all that down, so all the dots are together, and then you pull them apart. In some sense, those are the galaxies that came later. The galaxies aren't moving.
Right.
The stain on the balloon doesn't move. It's the skin, the stretching between the spots. So, in fact, nothing piles up the way it does when a supernova explodes. Everything actually just gets more and more diffuse as the universe expands.
Holy crap, man.
Chuck blew a gasket.
I gotta
I
tell
don't
you,
know.
man, this is-
Chuck
I
will have to
know.
go home
Some
and
good
heal.
stuff.
This stuff is
It's
so,
some good
so
stuff.
like
All right,
wild.
next question.
Wild, man. All right, that was great. Thanks, Paul. All right, here we go. Let's go to Brendan Rico Suave. You just screw with me, Brendan. Okay. Brendan wants to know this. I've recently heard of a new study that states the universe is thought to be in the shape of a loop, whereas previously it was thought to be flat. But in the explanation given, the nature of the loop shape states that it travels far enough in one direction that you'll end up back where you started, which is what we talked about earlier. My question is, wouldn't this happen regardless of actual shapes of the universe? So his point is like, no matter what you shape it, if would that happen?
Yeah. And I think that you can say...
I think that we have to take a break.
Oh, wow.
I should have seen that at the corner of my eye.
When we come back, Janna Levin is going to tell us, do we live in a loop universe or not on Star Talk?
Are you always taking care of your family? Do you often take care of others and not yourself? Well, now's the time to take care of yourself because you deserve it. Teladoc gives you access to licensed therapists to help you get back to feeling your best, to feeling like yourself again. Sometimes we don't know how much we need to talk to somebody. Take it from me personally. During the entire pandemic, I have had virtual sessions, and it has been such an incredible help. Now, with Teladoc, you can speak to a licensed therapist by phone or video. Therapy appointments are available 7 days a week from 7 a.m. to 9 p.m. local time. Hey, maybe you're feeling overwhelmed. Maybe you feel stressed or anxious or depressed or lonely, or you might be struggling with a family issue. Teladoc can help. No need to wait months to get a therapist. Teladoc is committed to facilitating great therapeutic matches so they make it easy to change counselors if needed for free. Teladoc therapy is available through most insurance or employers, and individual plans are also available. Download the app or visit teladoc.com/StarTalk today to get started. TELADOC.com/StarTalk. You know you're ready to earn your degree, but you need a university that works with your busy schedule. At WGU, their programs were built to be flexible. WGU offers a quality degree program that's affordable, flexible, and even makes it possible to graduate faster. You can earn a respected bachelor's or master's degree for under $8,700 per year, fees included. What? What year is this? See what WGU's competency-based programs can offer you. There are no set login times and 24/7 access to most coursework, so that means you can earn your respected bachelor's or master's degree on your own time. WGU's low flat rate tuition covers as many courses as you can complete each term. That means you can use what you have to get what you want. Take your skills and use them to graduate faster. Get your $65 application fee waived at wgu.edu/StarTalk. That's wgu.edu/StarTalk for your $65 application fee waived.
We're back. Cosmic Queries, Star Talk. Chuck Nice, my co-host.
Thank you.
All right. Janna Levin, friend, colleague up at Barnard in Columbia, doing that physics thing, cosmology.
Someone's got to do it.
Somebody's
gotta
got
do
to blow people's cosmological minds. And so tell us, as the question had asked, would the universe loop back on itself no matter its shape?
So not necessarily.
How do you know what shape the universe is in the first place?
Yeah, it's really, we don't ultimately know the shape. We know that we can see the distance light has been able to travel since the Big Bang, because we can't see anything faster than the limit of the speed of light travel time. And we know that the universe is expanding. So that's actually 92 billion light years across about. That's what we call the observable universe. Now, it's possible that it's not 92 billion light years across, that even within that range that the universe has folded back onto itself in some way, and we're actually seeing repeats of things. We're starting to see, it's kind of like a hall of mirrors thing. We're starting to see the light multiple times.
How would you know?
Yeah, I was going to say, how do you figure that out?
It is very, very hard to figure out. So there have been extremely clever ideas, and most of them
If I get my telescope and look out and I see Chuck waving at me?
Yeah, right, exactly. Right, when he was a little baby. Yeah.
You hear the one about the... Right, okay.
So it's true, we're looking at ourselves in the past, which is very hard to distinguish. For instance, if we're looking at galaxies, that's very hard to do. But there are patterns in the hot and cold spots left over from the Big Bang if it fits into a specific shape. So imagine something just totally platonically beautiful and crazy, that the universe is like a dodecahedron, all of whose faces are glued together. So it's like crazy origami. That thing is, there has so many loops. And it's
20-sided.
Yeah, that is
triangles.
Right, and
sides.
that is conceivable, kind of what we call topology or connectedness of the space. It would actually start to imprint that the patterns of the dodecahedron in the light left over from the Big Bang. So if you imagine there's tiny little hot and cold spots that you would start to see in the distribution of the hot and cold spots. That shape would be reflected in a very subtle way.
Really?
Yeah. So the reason
you don't mean reflected literally. You mean manifested.
Manifested.
Right. Yes.
So how the leopard got its spots is actually a very similar mathematical problem, because you're asking about enzymes being high or low in the developing embryo, and it turns out that the shape and the size of the animal, and like whether it's tubular or when those spots are hitting it, that it will determine what kind of spots the animal gets.
In an actual leopard.
In an actual leopard, zebra, stripes, like these things are things you can predict by solving for the mathematics of things that are above a certain threshold or below a certain threshold, that pattern of stripes or spots will reflect the geometry of the
animal.
animal.
And the Black Panther is a leopard. You knew that?
Yes, I did know that.
And the Black Panther has spots.
Now that
on
I
its
didn't
skin?
know.
It has spots.
On its skin.
If you look very carefully, you can see the spots.
Right.
Oh, wow.
Yeah.
Amazing. Well, how the universe got its spots is a similar mathematical problem. We're solving for hot and cold spots in a particular geometry when the universe was like a developing embryo, basically. And this goes back to Alan Turing, who solved some of these problems for the animal.
But like a Black Panther, does the universe care about injustices to the black man?
Apparently not, Chuck.
Apparently not.
If this is any evidence... If this planet is any evidence...
Just to bring that into modern reference.
Right.
Or does the universe have vibranium?
There you go.
I'm just saying. Just asking.
Well, we can hope that we're the bad example, and then elsewhere in the universe there are better examples.
Nice. Well said. Well said.
All right, Chuck, what else you got?
All right, here we go. This is Tim Braid, who wants to know this. A very recent study in the Astrophysical Journal found that galaxies may be rotating in sync with other galaxies millions of light years away. Galaxies separated by 6 megaparsecs were found directly interacting with each other. What is your opinion on this? First of all, is that empirical? The fact that these galaxies were actually interacting with one another?
I think that study is probably still controversial and probably still requires
probably wrong. I'll try. I'll be your translator. Okay, go.
I can't
That's
say.
an interesting study. Probably wrong.
Yeah.
It's controversial. Probably wrong.
These things can happen, but it just sounds not that likely. And so there will be a lot of people doing observations in different wave bands with different perspectives to try to break any possibility that it's a quirk of this particular observation. But 6 megaparsecs, that's pretty far away.
Yeah.
And so you would think that you would be dominated there by the expansion of the universe and not interactions. We definitely interact with other galaxies. That's not a big surprise. So Andromeda,
ones,
Andromeda's, we're going to collide with Andromeda. That's a happy future. Like, imagine when Andromeda gets much closer, how cool the night sky is going to be.
Hey, girl.
It's going to be like right there. You're going to see a whole
Actually,
galaxy.
it won't be as cool as you think. I'll tell you at the end of your answer, though. It's
Oh.
not going to be as cool as you
Because
think.
is it coming in edge on?
No.
You can tell me
I'll
it's
tell you
not
why
face
in a
on?
minute.
Okay.
It's a disturbing reason why it's not going to be cool.
Well,
So now, speaking of edge on, I'm sorry because I'm
Yeah.
a little all over the place,
Yeah.
here, but I got to get this in before we move on.
Yeah.
So, speaking of edge on, so if you're looking at something edge on, how do we flip it to get the imagery to know that we were looking at the disk from the edge?
So we do that with our own Milky Way. We're in the Milky Way, so we're seeing the rest of the galaxy edge on.
Right.
We've never seen the Milky Way as
From
human beings from above, but we have these beautiful constructions because we just map things as accurately as we understand where they are also in space.
Okay.
So we build an atlas of it basically. You build a numerical model based on all of your observations of the Milky Way, the gas, the dust, the stars, everything, where the spirals are, where the gaps are, and then you just allow yourself to move in that digital world and look down from above. But it's an experiment.
So
it's
it's the
numerical
modern
experiment.
version of map making because
Right.
you
Yeah,
make a
that's
map in
map
3
making.
dimensions.
Exactly.
Yeah.
And once you have a map, you can go anywhere you want. With
Right.
a 3-dimensional map, you can go anywhere.
Yeah, you
and
can-
plus, we see all the gas and we're kind of flattened in the sky. And there are other galaxies out there that are flattened, and we can see them at all. Not one galaxy at different angles, but a million galaxies all scattered in random angles. And
Right.
so it's pretty easy to figure out what we look like by looking at
By
others.
looking at others.
Yeah.
Adding,
And-
adding
Yeah,
Right.
and that's what we
data.
look like until we collide with Andromeda. But one of the things I took solace in, but I feel like Neil's about to
No,
make me
I
very
have to- I'm
uncomfortable.
sorry.
But the whole solar system's supposed to stay together, right, and get knocked around.
We should stay together.
So we might end up in Andromeda before we fully collide. Like they could pass each other, they could collide, move through each other, and we could end up in Andromeda looking at the Milky Way.
And that distinction-
Milky Way, we're going to leave a forward and address.
But what'll happen is there'll be a lot of sort of dissipated energy, and the system. Well, they'll of course pass through each other and back and forth. We've done this on a computer, and it's like a rubber band kind of thing, and it kind of dies
yeah.
down, and it settles into one double large massive system.
Okay, so what's the bad news?
Okay, so I hate to break the news.
That
to
sounds
you.
like good news to me.
Okay.
Yeah.
So if Andromeda were 100 times closer, it wouldn't be any brighter on the sky.
Interesting.
Yeah,
Okay, you've lost me. You totally lost me.
I'll tell you why. Okay.
Yeah, tell me why. 'Cause it's not obvious.
Okay, I'm gonna tell you.
Yeah.
I'm gonna tell you.
Okay.
Can I tell you? Okay. All right. So Andromeda has a certain size on the sky, correct?
Right.
Okay. It has a certain extent. And on a very dark night, not in the city, but where the moon is not out, you can see this fuzzy thing in the sky. So that's in the Andromeda galaxy. It's 2 million light years away. All right. There's a certain amount of light coming from Andromeda in that patch on the sky.
Right.
So we reference its something called a surface brightness. It is how bright is Andromeda over that patch of sky, over that surface patch on the sky. Surface brightness. Okay? If we bring it half as far away, okay, make it only half as far. It is how many times brighter?
It should go like the square.
Like the square.
But then the area
It'll be
is also
4
going-
times brighter.
But the area is going to
area
go
is
like
up
the square.
by a factor of 4.
Yeah. So
So the whole system is getting brighter, but
Right.
the surface area is remaining the same.
Right.
So it is not going to be more apparent to you in the night sky than our own Milky Way is on our own night sky. Right. I'm very sad to report that. I'm just sad.
but it'll look cool.
It'll look cool.
No, it'll just still be fuzzy. Can I see it? You got to get out of the city, get rid of the full
Right.
moon. Now I see the colliding galaxy.
Right.
No, I'm sorry. I'm very sorry about this.
Okay.
Janna, I'm sorry to
That's right.
report this.
That's right. I'm
It'll just look like our own Milky Way galaxy.
yeah.
If Andromeda were right here next to
Yeah.
us, it would
Right.
just look like our Milky Way in
Yeah.
the night sky, which
Yeah.
you cannot see from New York
Which
City.
you cannot see from New York City.
Okay.
It is
Okay.
true. But you can see it with one of those apps. Like you can just, you can hold it. It could
Hold
be
up
like
your smartphone.
Hold up your
you
smartphone.
have to hold it, and it could be like down there, and it'll show you like a beautiful.
Show you Andromeda on its
Yeah.
way, and you pump up the
Right.
the intensity.
Who needs eyes?
I love it.
Overrated.
You know
It
what?
is true.
I'm gonna get-
We are practically blind.
This is
know.
the new
What?
model for astronomy.
Yeah.
Who
No,
needs
Who needs eyes?
we're becoming cyborgish.
She
you
is
know?
so right on this, Chuck.
Yeah.
Chuck. We
cool glasses.
as the centuries went on, we discovered how blind we actually were.
yeah, that's amazing.
Yeah.
All right, there we go. Okay, let's move on to David.
Oh, by the way,
go ahead.
those Hubble photos,
Yes.
if you go to those objects, you don't see what the Hubble saw because the Hubble sees better than you do.
Right.
A lot better.
A lot better.
Yeah.
I mean, if you could just like stare at it for 10 days.
Or if your eyeballs were
Right.
like
gargantuan.
then
Yeah.
it'll look like what the Hubble sees.
Right.
Yeah.
All right.
Cool. All right, this is David Eduardo Perales Martinez, who wants
Oh,
to
you
know.
did good there.
Yeah, well, not bad. You know, my wife.
Let me hear. One,
My wife is Puerto Rican.
so you get a little bit of, let me hear that again. Go.
David, or would be David Eduardo Perales Martinez.
Martinez.
Yes. Who says this? Why is it so hard to prove the existence of other dimensions? Thank you, David from Mexico or
Yeah.
Mexico.
I want to ask that a slightly different way.
Yeah.
Go ahead.
If there was another dimension as big as the three that we're in, would it completely manifest to us?
Probably. There's a hitch. So you would think, yes, as long as that dimension was very large, then we would be talking about a world in which this did not confine us, right? So let's say I have skin, which seems to separate my inside and my outside. But if there was
I see
another,
right inside you.
if there was another dimension, you could do like one of those spooky surgeries without
Yeah.
puncturing any skin. You could just like go in there and touch people's organs. Like this would not be a separation of inside and outside.
Well, there's also an analogy to that is if you only live in two dimensions, then you only have sort of height and width, you have height and width, but not depth. Right. So if you don't have depth, if I look at you in two dimensions, I can see all your organs.
And for you,
And I can just
skin
reach in
would
and
be
pull
a
out your
line.
spleen or whatever. And you
Operation.
Can't, you,
Yeah, it's a
great game.
You can't see because you're in and all you see is the outer skin, which is just a line.
Which is just a line.
Yeah, and now
Which is-
our outer skin is a surface.
Right.
Right.
So, which is why, you can't actually probably have a very effective organism in just two dimensions because let's say they had a mouth and a tube going all the way through them, it would actually cut the two sides in half.
Yeah.
So you can't have what we consider to be normal metabolic functions of, okay, anyway.
You know what else you don't have? You don't have porosity in two dimensions.
Yeah,
Okay,
you
tell
can't
me
have
what porosity is.
So if you drop water on soil and then it just soaks in.
Right.
Or you drop it on a sponge and it soaks in.
Okay.
In two dimensions, there's no such thing as... there's
no
such
soaking.
thing- There's no
No
soaking.
soaking in.
Right.
So you just have a bulb of water
Bubble of water, correct.
sitting on top of it.
Because porosity enables... you have let's say two rocks are touching here, but then the water can just go around another side of the rock.
Right.
But in two dimensions where they touch, there is no way past it. And
Right.
It'll just stay above it.
Is that where you're able to smell what the rock is cooking? Okay. I'm sorry.
No, I'm
we're like,
That was, don't worry.
So here I will tell you this: that some people argue that the reason why the universe is three-dimensional is because the universe tries to be many different ways. Like, well, there may have been an infinite number of big bangs in the past and the future. Can't really talk about it in temporal relativeness, but if the universe created a two-dimensionally large universe with all the rest rolled up and small, you couldn't have organisms in that universe to ask the questions.
Wow.
So you'd need at least three. And then let's say you had four spatial dimensions. Then you have the problem of things drift away from each other in such a way that it's hard to have organized systems. So just like Neil is describing, a two-dimensional creature isn't aware of the third dimension, but if they became aware, they could just kind of float away from their city, right? It becomes, you have more volume of space to fill. The cross-section for interaction goes down. So now if you add another dimension, the cross-section for interaction goes down again. So it could be
but
that-
we successfully exist in three dimensions in spite of the challenges the two-dimensional creature would face upon accessing a third dimension.
Right.
So why
Maybe
aren't-
three is
why-
optimal.
Why don't four-dimensional creatures pity us?
Yeah. Right. Well, that is a good question. Could the complexity, I'm not saying they're true arguments, but some people argue that you couldn't in the four dimensions get the successful complexity. And some of those arguments they get complicated based on string theory, cross sections and annihilations into photons and what's left over after all of these things in the Big Bang. It turns out that only a tiny, tiny bit of stable matter is left over already in three dimensions from the Big
So
Bang.
it could be. Wait a minute. Let me kind of agree with what you just said, even though I just
Yeah.
disagreed. What you're saying is, in three dimensions, it could be optimal for particles to get together and make molecules, and molecules to make macroscopic objects. If you add a fourth dimension, you're adding a degree of freedom of where things can hang out and possibly never then find each other.
Yeah,
Wow.
Ever
it could
again.
be if you think about the volume of the universe is going up radically with the volume of dimensions.
Yes.
Then you're diluting everything in the universe
Concentration of what could
significantly.
be. Ooh.
But there, so Andy, these arguments.
So the fact that you're even asking that question means you are a being in an optimized universe to even pose the question in the first place.
So the two-dimensional people couldn't ask this question?
Right, because they couldn't be two-dimensional
Right.
people because the structures are too simple to allow.
And four-dimensional people, there's too much play space.
So let's take it. Let's take you. Your first question was, would we know it if the other dimensions were large? Here's the hitch. You would think we would, but here's the hitch. Even if all of those problems were solvable, there is an argument that we could be glued to a kind of a membrane, which is a three-dimensional surface floating in this higher dimensional space, and we're
so
like
what
glued
glues us
to
there?
it. It's the
Elmers.
the Elmers. The way the fundamental forces work between
They keep us there.
they keep
Right.
us on the membrane, and the only
Wow.
thing that happily goes off the membrane is gravity itself.
Right. Oh, man.
So that all other forces are glued to this membrane. That's where they live. So that you would think like a particle to you interacting with that membrane could be a string in the higher dimensional space.
Passing through your space,
Whose
manifesting
end- right.
as a particle.
Manifesting as a particle. So like imagine cutting a string, it would look to you like a dot.
Right.
An infinitely thin string. So
And
That
I would-
is
so
wild.
we think
the way I
it's
think about
particle
in two
physics.
dimensions,
Yeah.
I think of passing a hollow sphere through two dimensions. What would that look like to the two-dimensional people? They'd see a dot and they'd say, "Oh, that's cool."
right.
Oh, then it becomes like a circle.
Circle.
And it gets bigger and bigger and bigger. Then it maximizes out at the diameter, but they don't know this. And then it gets smaller, then it gets a point and disappears. And
And they have no idea
they have no
that
idea.
a big sphere
and,
just
and
passed
all
through
kinds
their
of
whole
mystical, magical
existence.
hypotheses come out.
Yeah.
And the scientists analyze it.
Yeah.
And we just say stuff pops in and out of existence. We don't know why.
So one of the absolutely. So one of the things that we've worked on with extra dimensions that make them not just an oddity, but maybe something
I
we've
like
already
that.
observed.
One of the things we worked on our extra dimensions. This, Janna, what's
As
in your
you do.
basement? She's a superhero nemesis character in the
You know,
making.
my superhero character name is Jan 11.
Oh,
Isn't it good? And it's a prime number.
Jan.
I mean,
11.
I've got to work that
No,
somehow.
You don't want
I
to be
need a
super. You want to
cape.
be the nemesis.
Oh,
that's
that's
way more
fun,
fun.
too. It
Because
is
you can
way
be
more
diabolical
fun.
with the science.
That's
Yeah,
Jan
I should
12.
My evil twin,
Your
Jan
evil
12.
twin, Jan 12.
So the interesting thing there that people have thought about is that maybe something like dark energy is actually a quantum
just about to say
phenomena
that.
trapped in the extra dimensions that we can't perceive the extra dimensions directly, but we're indirectly perceiving them through the dark energy.
Or dark matter is regular matter in the higher dimensions leaking over
Into right
and which
through
is
this membrane,
and which
which
is
the
doing
tra-
this, and it's just mysteriously there.
Yeah, people have definitely wondered
so
if dark matter
gravity
can have to do
is
with
the
extra
thing
dimensions.
that is the medium. Is that the deal?
Gravity is space-time, so gravity can't be confined
Gotcha.
to, otherwise there would be no meaning to the extra dimension.
Stupid. You
So-
know? Everybody knows that.
Everybody knows that, Chuck. Hell's your problem.
Chuck, we got to take a quick break.
Okay.
When we come back, more with Janna Levin on the edge of the universe and beyond when Star Talk returns.
Hey, we'd like to give a Patreon shout out to the following Patreon patrons: Roy Hill Percival, Jose Clark, and Dr. Janet L. Walsh. Thanks so much, guys, for helping us make this little trip through the cosmos. And if you would like to support us on Patreon, go to patreon.com.
We're back. Star Talk, Cosmic Queries, the edge of the universe. There's only one person in arm's reach out there who could do this. Janna Levin. Janna. She's our go-to person.
Yes.
For
I
extra
love being the
dimensions.
go-to person. It's the best.
Totally the best.
I have actually written papers on extra dimensions. It is a genuine
It's a thing.
direction in my in my research is to think about
So
this.
when she disappears,
Well, no.
Well, no.
Wouldn't that just be so cool?
Yeah, you just
Buzz
go-
just like got up and then like went into the fourth dimension, and then might just would
is
disappear.
how Monsters Inc. worked.
Yeah.
Monsters
yeah.
Inc. These are doors
Yeah.
that came out of the factory.
Right.
This was an uncelebrated fact of that movie. These are four-dimensional portals. They're basically wormholes.
They're
right?
amazing.
Each door, this is the door to the kid's room. And the monster takes it home at the end of the day, and they open the door, and on the other side of the door is the kid's closet.
Right.
Nice.
Okay?
So great.
And then they come out in the closet, scare the kid, go back through the door, and they're back at home.
It is a great movie.
Great. Okay.
I love it. All
What else
right,
you got?
let's go to. Well, you know what? Let's go back to a Patreon patron. This is Solarcero de Rai. Okay, who says, "What do y'all think about the?" You like that?
I like it. That was good. That was good.
What do y'all think about the idea that matter consumed by black holes has been recycled and manifested back into the universe as dark energy?
So matter coming out the other side, maybe.
Right.
Okay.
So, is there any correlation between the matter consumed by black holes and dark energy? Could black holes and dark energy, dark matter, be different sides of the same coin?
Well, I mean, where to begin with this?
This is a lot.
I could
we
lead
could
off by
say-
saying there's an urge to take everything you don't know and assume it's related.
Right.
So I've got people talking about dark matter,
Right.
consciousness, God,
Right.
and dark energy all
Right.
as one thing.
Right.
And,
Somebody.
and quantum spookiness.
Yeah, someone asked me when they take ayahuasca, is it possible that they have gone to a higher dimensional space?
Okay.
Well, okay. And
But my answer to, in an attempt to not be totally dismissive, was to say, well, if it's a platonic form that we can learn about by exploring the mind, then in that sense, maybe.
right.
Right? Like a perfect circle doesn't exist in reality, nor will a perfect circle ever exist anywhere in the universe. But you can touch it in your mind, right?
Right.
And it's an experiment we can all perform so that in that sense we go places.
Unlocking secrets of the
Unlocking
mind, if not
secrets of the
secrets
mind.
of the physical universe itself.
Yes. Yes.
Okay, great.
In other words, you high.
So what do you say about dark matter, dark energy?
So okay, so let's just start
Anything
with
dark.
the falling in, coming out. So there were very early on people who thought a black hole could be bigger on the inside than the outside. It could be as big as an entire universe on the inside. It could actually lead to a white hole, which is basically a big bang. So you fall into the black hole, and that is completely confined by the event horizon. Nothing ever comes out, but inside it is like something as big as an entire universe.
Right.
Another universe. And that universe would
TARDIS.
remain
Like, yeah,
a
bigger on the
TARDIS.
inside
It's
than on the
exactly
outside. Right.
Exactly. It's just like Doctor Who's TARDIS, and so we would never know about that universe. It would not communicate with ours.
Check Chuck's street cred. TARDIS is an acronym for what?
Oh, no. Oh,
Can't
no.
remember it all.
Phone booth in London?
Yes.
I don't know. What
Time and relative dimension in space.
time and relative dimension in space?
TARDIS.
Wow,
There
cool.
you go.
All
Okay.
right, go on.
Usually
Nice
the
job.
and doesn't make it into the acronym. I'm just going to say, Okay, so that was an interesting idea, and a lot of people object to it because it in some subtle way suggests an unstableness to big bangs that might make it so that this world couldn't be stable if that were true. But honestly, it's not completely off the table. There's a lot. You could talk to some very important early relativists, and they will still say that's what happens.
Relativist, an expert on relativity.
On relativity. So then there's a totally separate question about dark matter. There is a suggestion that the black holes themselves could be dark matter, meaning that they are invisible, like dark matter is, technically, and they could populate the universe almost arguably large enough to explain this missing mass, this missing matter. It's on the edge. It's definitely under pressure.
Right, but there's a problem with like Big Bang nucleosynthesis. If it's ordinary matter,
The black holes don't have to be made by collapsing stars out of ordinary matter. But you're absolutely right. We don't know how to make enough
There's some
ordinary
issues.
matter.
There's some
Right. So they're
issues.
not made from stars.
so did I show you my black hole lunchbox?
Oh, let's do it.
Did I show you my...
I want to know what's inside the lunchbox,
An
but I can
infinite
never
lunch.
find out.
You can,
can
if you go in,
I? You
she
never
will
come
never
out.
come out.
Yeah.
If my hand goes in, will it never come out? Yeah, exactly.
Okay.
And inside of it is a black hole
Sure.
thermos. But of course,
Okay.
It is confusing. If you fall into a black hole like this, I guess you can't see your hands. Very confusing.
You'll disappear in front of yourself.
Yeah.
Okay.
So you have a black hole thermos, and it is filled with
Okay, so
Liquor.
this is an inversion of the known universe. Because in this particular case,
inside your black hole.
I have the Milky Way
Oh, God.
inside the black hole.
No, you did not.
He
Yes,
did
I
that.
did.
Yes.
You just
I
did not do
Totally
that.
did
I
that,
so
sir.
You
just
did
did.
not just
Did you
pull
see
a
our
Milky
faces?
Way out of a black hole.
Because the black hole's always inside the Milky Way.
I am just going to say that was the most committed joke I have ever seen in my life.
I'm just saying,
For those of you who
For how
don't have a
long has he been
camera,
waiting?
I'm just telling you, Neil had an actual Milky Way candy bar inside of a black hole thermos. Okay, that's what you
Inside my
guys-
black hole
inside of his
lunchbox.
black hole lunchbox. Okay,
You're just jealous. That's all.
I'm a little jealous of the black hole lunchbox. I gotta
Definitely a little
say.
bit jealous.
Yeah, it's kind of.
So the last question, which is pretty hard, is could they all be connected, the stuff that falls in and comes out? And classically, we would say no way. Event horizon separates everything from the inside, the outside. But then there's like quantum entanglement
Right.
across the event horizon. Maybe some particles on the inside are also the same thing as the particles on the outside. They're the same particles because of entanglement and wormholes and some crazy stuff that nobody really, it's all just very conjectural now. But maybe we'll come back in 20 years and we'll be like,
And we'll
figure
have
that out.
something for it.
Yeah.
We'll have the follow-up to this Cosmic Queries 20 years from now.
Yes,
We'll roll us in
exactly.
wheelchairs. Not you, but me and Chuck.
Because I'll be doing my regenerative medicine.
So we got to go
Lightning
lightning
round?
round here. Chuck,
All
let's
right.
do it.
Here we go.
So, Janna, you're going to answer in
Amped.
sound bites.
Okay,
Mm-hmm.
I'm amped.
This is Bunders85 on Instagram and wants to know this. I know it's off topic, but one of your last shows, you were talking about the information on the surface of a black hole. What do you mean by information? Do you mean temperature or speed or
What is information?
Ultimately, we are completely definable in terms of our quantum numbers. It's just list of facts about us, information about us, and relative locations and
My
organizations.
quantum
in those
number is
quantum
42.
numbers. So, of course, Niels is. So it's something as simple as your mass, electric
the
charge.
number of atoms in my body.
Well,
Is
let's
that a-
take a single fundamental particle in your body. It has mass, charge, spin, and it's identical to every, let's call it an electron in this case, every other electron, identical. One's not a little bit heavier, one's not a little bit lighter, and we're completely definable in terms of that information. And you cannot destroy that information.
Interesting.
And so in quantum mechanics, you stop thinking in this.
Wait, if I melt Chuck,
Yeah,
and he's a puddle.
technically, all of that information is still in the universe,
Right, it's
including
just
in the
arranged
heat that's
differently.
lost. It's just arranged differently.
arranged-
and
oh my God,
In
that's-
principle,
Wait,
it can be
no. How about the
reconstructed.
information?
thought, though. That's an awful thought.
If Chuck is a puddle on the ground,
Yeah.
that's a different Chuck from the Chuck I'm talking to right now. How's that information still there?
Yeah, so the
I will never change.
Well, technically,
talking.
changing having information preserved doesn't mean there can't be local change. Right, so I can definitely change things locally, but I still have to have the same information content
in the total system.
In the total system, so I have to be able to reconstruct something. It doesn't mean that there's no
With
change
what's in the system.
With what's in the system,
Got it.
But you don't have to necessarily be able to reconstruct the exact same thing. You
Well,
just have
in
to be able to
principle,
utilize the
you do.
same information.
Right. In principle, I should be able to, if I took a page of the encyclopedia and burnt it, I should be able to reconstruct it. In principle. Of course, nobody can ever really do that. It would
Right.
take longer than the age of the universe, and we don't have that kind of computing power. So there's physical impossibilities, but
Ignoring those complications.
ignoring those complications. But it's
We've
important
just solved teleportation.
So for the black hole, the argument is that what's actually might be happening is that the information as it's falling in, which is basically all, everything,
Right.
never actually makes it inside the black hole. It becomes encoded on the boundary, which is the event horizon. So it's actually a hologram.
All right,
So I got
lightning
you.
round here.
Lightning,
We gotta
let's
keep moving.
lightning. Okay.
Oh, wait,
here we
that
go,
was
here
not
we go.
lightning
Go.
enough. That wasn't
All right,
lightning enough.
okay, here we go.
That was
this
like-
is Elias82 from Instagram says, NASA reported that Voyager 2 discovered 2 new details about interstellar space. How does that change our understanding of dark energy beyond our solar system? Or does it?
It probably doesn't because it isn't a detector of dark energy or dark matter. We have no detectors of dark energy or dark matter yet. None successful. And so but it is amazing that it's the first human-made object that's gone interstellar. And that really is quite spectacular. It's just broken out of basically the sun's magnetic influence, so it's able to get cosmic rays and things that are protected in the solar system by the sun's
We used
magnetic
to think
field.
the solar system was how far out are the planets, and then you have like the Kuiper Belt of Comets, then you have the Oort cloud. And then you say, well, really, at what distance does an object no longer know that the sun is in this direction.
Right.
Because the sun has magnetic influences that go very far. And you reach the point where all the field measurements are sort of in this soup that permeates the entire galaxy. And so it's a transition from the sun is this way to I got stars in every direction.
Yeah.
Right.
And so
It's still moving so slowly that it will take, 10,000 years to reach another?
No, 70,000 years.
70,000 years.
All right. We're lightning round. This is from Robert Weaver, who says, thanks so much for educating and inspiring us. What news in science do you find most interesting and important right now with respect to your field?
Wow,
Ooh,
that's
good
a
one.
great question. Well, we do live
In a soundbite.
Yeah. we are in a very lucky time because we have discovered bare black holes in this miraculous way. So I do think that the most exciting
And
things
one of them
have
has
to
a Milky
do.
Way inside
One
of
of them has is eating Neil's Milky Way. So I do think it is where the small meets the large, and it will be that way for a long time, meaning what the Big Bang tells us about dark matter and dark energy and the universe on the larger scale, and why those things are folded together, thinking about the universe on the biggest scale and on the small scale.
So where quantum physics meets general relativity
For sure.
is an unresolved territory.
That's right, and so that's why we use all these really
It's the
extreme
Badlands.
settings. Right. If you wanna understand where quantum mechanics meets gravity, you got to do it in the Big Bang or on black holes.
All right. Next,
Okay,
Jack.
here we go. This is Pablo Gristensko. I don't know, Pablo. I'm sorry. Can you please help me put inside my head one more dimension? 3 is fine, but how can I grasp more? That's
What do you do with people?
what do you do with people to let them understand?
I think it is absolutely imperative that everyone understands that nobody can just blanketly visualize higher dimensions. We're accustomed to looking at dimensions from the outside looking down. We can't do that. Right. So what we can do are the kinds of things that Neil was describing earlier, which is imagine 3-dimensional cross-sections of things. So visualizing a hypersphere, which is a higher dimensional sphere, as an intersection of it with our 3 dimensions, and it would be a series of spheres.
Ever-growing, right.
That would max out, and then
Right.
spheres would go back. But the one last thing is to do the difficult example of being a flatlander, and you will actually, just by going down a dimension,
It'll
start
help.
to get it.
Yeah. And I can add that if I've said this in a couple of Star Talks before, but there's another moment to do so. If a line is bounded by points and a square is bounded by lines and a cube is bounded by squares, then a hypercube is bounded by 3-dimensional cubes. The sides of a hypercube are 3-dimensional cubes. Right. And you just
So it's always-
mathematically you just work your way
keep
up.
going up.
You just keep going up. And the
Right.
math will take you there.
There
Math
you go.
will
Math.
set you free.
There you go.
This is a real example where the math makes it a lot easier than trying to visualize it.
Okay, there you go.
Said no one ever. Math. Let's convert this to math to make it easier.
So great.
For higher dimensional differential geometry.
That's
All right,
awesome.
go.
Okay, this is Eric Svensson. Mark Eric Svensson. He says this. Neil, you have said before the dark matter should really be called dark gravity, and it really stuck with me and helped me understand it better. Do you have a similar and alternate name for dark energy that better summarizes the phenomenon?
I'll give it a shot, but I want to hear
Let's see what Janna says.
Janna says.
Janna.
I would say I would just call it dark expansion stuff. We don't know what is energy.
Dark
We don't
stretching.
stretchy stuff.
Dark stretchy.
But definitely dark gravity is what dark matter is. It is literally dark gravity. And I'm totally cool with that.
Are you totally cool with that?
Totally cool with
Well,
that.
is a neutrino dark gravity?
Uh-oh.
Sure.
That's a form of dark matter. Like, we have examples of forms of dark matter that we have detected. They're just not plentiful enough to explain so much of it.
Yeah,
But
well,
there are things called neutrinos, which we do detect, and they are dark, meaning they don't interact with light.
Right.
I wouldn't call neutrinos dark gravity.
Wow.
I'm pushing back a
No,
little
but
on
it's
that.
just pushing back. Just messing with me.
Let me tell you something. That was rough, man.
Oh, you got front row seat on
Yeah,
the
I'm-
nerd fight.
Right now, I got my popcorn. I'm just like,
Nerd fight.
oh, this is good.
I will jump in with the dark energy, though. What if we thought of it as like an invisible ocean? Because that's sort of what the dark energy is around us all the time, and it's as though we're in a storm of dark particles and dark
Vacuum
energy.
bath.
It's just
A
that
vacuum
it's
bath.
really that it's invisible. is the thing. You can see right through it.
Okay.
It's not that if you had it in your hands, it would look dark.
Right.
It's invisible.
Right.
Right. So both dark and energy really don't apply. We need a better name for it.
Yeah.
Okay.
Yeah.
There you go. So it's really in the name.
Vacuum bath. Next one.
All right.
Last one, real fast.
Okay.
Janna,
Here we
half
go.
a soundbite.
Here we go. This is Hector Salazar, who says this. Can other universes influence or overlap with our own? And is there any evidence that this might be happening?
This would be the parallel universe.
Yeah. Very speculative, but if you consider a universe, let's say we're floating on a three-dimensional membrane in a higher dimensional space, and there's another one of those floating also in the higher dimensional space, parallel, or in some sense. And
Now, do they both share this membrane you're talking
They
about?
No,
do
it'd be a different
not. They'd be
membrane.
two separate membranes.
Two
So in
separate
that sense, we would
membranes.
call
Okay.
them universes.
Right.
And yes, it is possible that they have interacted in the past and that there would be some archaeological record of that or in the future.
If they intersect, is there an intersection line, a three-dimensional line?
In which you live in both universes.
Ooh.
Like a party wall.
Ooh.
So technically, if you mean by universe the galaxies and everything you see, and not the whole space-time, then technically, yes, two universes, two membranes can interact and can coexist.
I want that.
Yeah, I like the idea of living on the boundary between two universes.
Only if the people in the other universes aren't a-holes.
And as long as the laws of physics there are the same as
Same as
yours.
ours.
Because you don't want to decompose into a puddle of goo.
Yeah, that would be bad.
That would be bad. The charge of the electron is different.
Bad.
Bad. Very bad. Bad universe. Stay away. We got to call it quits there. Jen, it's always good to have you on, Jen.
It's always fun to be here.
We don't have you enough.
Oh, I love
Chuck,
it.
Thanks. So much fun.
Good, man.
So much fun.
Janna Levin, professor of physics up at Columbia and Barnard College. I'm Neil deGrasse Tyson, your personal astrophysicist, signing off for Star Talk, bidding you, as always, to keep looking up.
So you're ready to earn your degree, but you need a university that works with your schedule. Well, WGU and their programs are built to be flexible. WGU offers a quality degree program that's affordable and even makes it possible to graduate faster. Plus, you can earn a respected bachelor's or master's degree for under $8,700 per year, fees included. That's right, you heard me. That is the correct, $8,700 per year. Let your experience and dedication help you earn your degree faster. See what WGU's competency-based programs can offer you. With no set login times and 24/7 access to most coursework, you can really earn a respected bachelor's or master's degree on your own schedule. The low tuition rate covers as many courses as you can complete each term. That means the faster you learn, the more you'll save. Get your $65 application fee waived at wgu.edu/StarTalk. That's wgu.edu/StarTalk for your $65 application fee. Poof, gone, waived. Poof, gone, waived.